right, we're recording. It's Thursday, October 24th, 10:58. Welcome, everyone. We're about to have a discussion about the image encryption in Glance and how it interoperates with Cinder and Nova. Does anyone know how to make Google Meet just allow everyone in without having to say admit specifically? I thought it would be a setting, but I can't seem to find it.
I think you might have to like sign in as the owner of the meeting or something to do it.
I thought it was an org-wide thing that they could just say, don't ever allow that to be automatic.
Yeah, I think it's intentionally left the way it is.
Yeah.
So the alternative would be to use your public Gmail account, but then you're limited to an hour meeting,
which would be a good thing. But
yeah, that's kind of a feature.
Well,
maybe
it's
not.
just yeah, okay.
Fair enough. I can click admit, no problem. So are we waiting on Glance? They've got technically a minute to go. So
who else from Glance are you expecting?
I guess Cyril.
Oh, okay. I guess we're not getting Melanie. I'm not sure. Yeah, guess we're not.
I think we can start and Cyril will join short.
Abhishek, if that was you speaking, we could barely hear you.
Is it okay now?
Slightly.
Still low for me.
It's still not audible.
I can hear you, but it's pretty low. But I'm pretty sure he was saying we should get started.
So this topic was proposed on the Etherpad by Nix M-H-E-N, and Luzi, L-U-Z-I. Are either of you present?
Yes,
Okay.
M-H-A-N is here. You can call me Marcus.
Marcus,
yeah,
welcome.
right. And my colleague Josephine, with the nickname Lucy, is also here. Do you hear me okay? Is it
Loud and
audible?
clear.
Okay,
Yes,
that's
we're
great.
recording, so you are good to go.
Okay, right. So we brought this topic here because that's a long-standing thing now. So in the past, we were trying to contribute image encryption support for a range of services, including most prominently Cinder, Nova, and Glance, because they are mostly handling images in some way. And there have been multiple iterations by now. We started off with a GPG-based encryption, some of you might remember. Then after some discussion, we moved to a LUKS encryption, which is more similar to what Cinder is already doing. And also Nova starts supporting with the QCOW2 format. And we were preparing patch sets for various libraries and services. The patch set for OSBRIG was already merged, I think, a few months ago. And then we moved on to the patch sets for the service layer, for Glance and Cinder and so on. And initially, that at least is the background story, we had a discussion mostly with the Glance guys about how to actually label these images and how to categorize them. And initially, we agreed on not introducing a new container format or disk format, but simply handling this with metadata, with additional metadata properties alone. This was before the row of CVEs that actually exposed some problems in the overly optimistic image handling with QCOW formats and VMDK and whatever. And by the time we had the patch sets ready, there was some discussion spawning around if we might want to reconsider how we label and handle those image formats, and if it wouldn't be better to actually use a new container or disk format so that the images can be checked in an earlier stage than when they would actually hit some QEMU image convert command or something where possibilities for vulnerabilities could pop up again. So we had a few rounds of smaller discussions around this in the Glance and Cinder IRC meetings, as well as our weekly pop-up meeting about image encryption, but we soon decided that we want to bring it up in the PTG because we need all the parties involved to actually agree on an interoperable format here. So the actual question, or the primary question, would be what kind of container format or disk format extension we would need to introduce in Glance and the other services, and how those would look like. We have, and this is also summarized in the Etherpad as well, we have at least two cases to consider from our point of view. We have raw LUKS format, like Cinder can produce right now already by simply copying its encrypted volumes. And we have the QCOW2 wrapped LUKS format, which is a QCOW2 container that internally has LUKS encrypted blocks. And this, for instance, yeah.
Can I just ask a question about that? I either keep forgetting this or haven't established it in my head enough. But if you have the second format, the QEMU with LUKS blocks in it, and you do a QEMU image convert from that to raw, do you end up with a LUKS disk that you could potentially like DD to a disk and have it be regular LUKS format?
Yes.
Okay.
You can instruct QEMU image convert to convert between raw LUKS and the QCOW2 wrapped version of LUKS in any direction.
Okay.
I've tested this.
Okay. I guess I knew. Yeah. That what I'm trying to figure out is, QCOW is a sparse disk format where you can have you're trying to represent a linear contiguous disk, but maybe without some of the blocks and in potentially any order, right? So I guess what I'm asking is the thing that QCOW is simulating exactly a LUX disk, but in QCOW format? Or like, does it just have to write the blocks out in the right order in order to convert, or does it have to do other stuff? Because if it, well, I guess that, yeah. So do you know that to be the case? Did that make sense?
Eric, you wanted to say something?
So I was studying up on this format a while ago for some Cinder stuff with it. And I think there's some subtlety there where it's not exactly a full LUX image inside of a QCOW2 wrapper. Because if I remember correctly, the way that they actually implement QCOW2 with LUX, some of the LUX header information that would normally just be in the LUX raw volume is actually in the QCOW2 header and not like in the QCOW2 data section.
Where it would be virtually for the virtual disk that it's simulating, right?
There's like a weird interleaving of the two layers that happens in that format, I think. And there's some kind of integrity reason that they do it that way, but it basically, it doesn't work exactly the way that most people would assume that it would work this way.
That's what I was worried about. I assume that they also maybe do that so that they can just grab their own header structures and know enough about the disk without having to go like find the LUX block in the data payload in order to be able to do something.
Probably, because the LUX format, even when you're just using regular disks, I think the format allows like a detached header where you have one block device that's the data and then another block device somewhere else that's the LUX header stuff. So I assume it's using something kind of like that.
Yeah. Okay. Well, the reason I'm asking is that that to me signals that the QCOW encrypted format is not just a wrapped LUX. I mean, it is not, based on what Eric just said. So therefore, we maybe shouldn't try to jump through hoops to represent it as that, and instead, treat it as either treat it as just QCOW with some metadata, or treat it as something else, but don't try to necessarily call it LUX with a QCOW, wrapper around it, because it's not exactly.
So we already had a similar discussion in one of the pop-up meetings on Monday, I believe, in the past, where we essentially figured out that this what you just described, having the QCOW2 feature of LUX encryption in there, is not actually a new disk format. It's actually the disk format QCOW2 with an additional feature support implemented that could be represented by an additional metadata attribute or something like OS encrypt key ID, like we intended. The only new format would be disk format called LUX, because this would be the raw one, which is not encompassed in any QCOW structure or anything, which is just raw LUX disk blocks in there. And then we would end up with only one new actual disk format. And we would need to figure out how to represent the nuances of the new disk format variant of QCOW2.
Yeah, right. So that's kind of what I'm saying I would lean towards, is keep the QCOW2 thing QCOW2. Metadata means you should expect the inside bits to be encrypted. The thing about LUX is I think it sounds like we agree on that part, and that will be the simplest, because the current inspector will find those QCOW things to be QCOW regardless of whether they're encrypted or not, because we don't even get into the bits that right now that we would even like see the difference. The problem with LUX as a disk format is that, well, actually, I guess I'm not even sure. I was going to say Lux kind of wraps something else, but I'm not sure that that's really a good way to look at it either, right? Because I think you still end up with a GPT and a partition table, and the Lux header is the first bit. I mean, it has to be, I guess. It's the first chunk of the partition, right? Because the partition is the thing that's encrypted, right?
From my understanding, if you have such an image, which is just a binary blob, then the first chunks of data are the Lux header, and anything after that is the encrypted stuff, which can be anything.
Well, okay, but but like on Linux, if I do, yeah, I guess that's true. So I can crypt set up a disk or a partition, right? And if I crypt set up a disk and then I partition it, there's going to be a GPT inside it. And
Yeah.
if I crypt set up and just do a MKFS into it, it's just going to be a file system, and the Lux header will be the first thing. The Lux will just be encrypting, you know, what we would consider to be a partition content. So yeah. So a Lux then, if this is I guess this is part of the confusion because it doesn't really map to physical bit. A PC machine cannot boot a Lux itself because there would be no partition table, no bootloader section, so it wouldn't work, right? So from a Nova perspective, you would not think that you could directly boot a Lux. The problem is that QEMU can do the Luxing for you, and then you end up with whatever is inside the Lux passed to Nova, which could be a GPT, would have to be a GPT in order for Nova to be able to boot it in the conventional sense.
Yeah, so you either have native Lux support in your hypervisor like QEMU and KVM, where the QEMU KVM layer handles the encryption and decryption and transparently passes the contents to the VM so that it appears just as any other hard disk, starting with the partition header or something. Or in the classical way, you use a device mapper to mount the unencrypted mount point somewhere on the system and pass that into the VM as a disk, which
that's still going to be
is effectively the same.
Right. So that's going to be whole disk as well, which means that if you expect it to be bootable, it needs to be a GPT. Okay. And we would never. Well, we could hand. I guess we could hand the raw encrypted bits to the guest, and then it would just have to do. You know, if we did some sort of more pass-through kind of a thing.
Yeah.
They would just have to interpret it as whatever. Okay. All right. So then, go ahead.
Yeah, just as a side note, I don't know if everybody in this room is actually aware of this, but in the way it's currently implemented, without any of our patch sets, you can actually construct this right now. If you forge a Lux encrypted disk file and you upload it to Glance, and you do the hexlify of the key, which internally happens in Cinder normally, then you can pass that image with the Cinder key ID. If you put a secret in Barbican, you can pass the Cinder encryption key ID as metadata to the Glance image, and then you can instruct Cinder to make a volume out of it, and it is able to transfer this in an encrypted Lux volume that is bootable in Nova. This already works, but you have to jump through hoops and know exactly what you're doing. That is absolutely not user-friendly, but it is possible.
Sure.
So we wouldn't want to change any major thing about that. We just want to make this a bit more usable and user-friendly so that this functionality, which is already halfway there, can also be used more extensively.
Sure. So I think that calling Lux a disk format the way it's currently used, I think that makes sense. Because it's the first layer that we're going to peel off and then hand whatever is inside directly to the consumer. And that's what Nova will do, right? Like we'll deluxify it at the host, whether that is crypt setup or native QEMU. And then whatever is inside, we will not interpret any further, which is the unsafe bit, and we'll hand that to the guest. And that, I assume, is also what Cinder does, which is it peels off the Lux, however it does it, and assumes that whatever is inside that needs to get written directly to the disk, right?
Yeah.
So that is equivalent to a QEMU image where either we are converting that to a flat file to write to a volume, or we're handling that at the hypervisor level and we're handing whatever is inside directly to the guest as a block device. So that makes the two things equivalent in terms of peel off one layer, don't look at anything else inside, and the consumer, whoever is the consumer, gets the raw bits in there. So if you put a VMDK inside of a QCow and you say it's a QCow, we peel off the QCow and hand the VMDK up, which will probably not be useful to you, but like that makes them consistent in their behavior. And I think that to me says that Lux should be a disk format.
Yeah, the other good thing about that is we have the compressed container format. So it's possible to upload a Lux as a Lux volume to glance, and if compression's on, it's actually going to be I forget I think it's a gzip. Yeah.
The problem is that will never compress much, but
Right.
That's fine. You can do it if you want. I guess I also kind of like what I just described, maybe, and then what you just described for compressed. Like I feel like maybe we need to come up with a meta definition of what container format and disk format mean to us, because they're very confused right now, because like AKI is a container format and a disk format and an image format and I don't know.
Let me just quote the glance documentation in the chat. So the glance documentation is pretty clear on that. It says the container format refers to whether the virtual machine image is in a file format that also contains metadata about the actual virtual machine.
Which is totally wrong, because that doesn't apply to compressed, right? It does apply to OVF, but not compressed, as far as I know. Marcus?
Yeah, I don't know. I just quoted the glance documentation, which I think is pretty clear, but I cannot. I cannot fix any discrepancies with the implementation or the actual usage of it. Just wanted to have a base to interpret this on, but yeah.
Okay.
So,
right.
And what I can infer from that is that at least the stuff that we are discussing about the low layer consistency of the disk or whatever is not the container format, because this seems to, or wants to represent a more overarching structure that also involves some other aspects of the resulting virtual machine other than just its disk. That is how I understand it.
Yeah, I think that I would have to sit down and do some thinking about how to describe them. I mean, there's so many inconsistencies that like any description is going to have a bunch of excepts in it or something. But I think that probably the intent was that disk format is the layer, the kind of encoding layer that gets peeled off by the virtualization layer. And I'm including Cinder in that, as part of the virtualization layer, or maybe you say at the infrastructure layer, right? Like disk format is the layer that gets peeled off by infrastructure to provide a block device to the guest. And then I would say maybe container format was supposed to be something that made transporting or storing the image easier. So that might be an interchange format, it might be compression to make the transport more efficient or something like that, but it's not, it's more related to transport and long-term storage than it is to the encoding of what the guest, what the consumer eventually sees as a, block device kind of a thing. But I feel like that a lot of the formats that we have in there probably violate that in various ways. But I think that Lux fits that definition in that Lux is getting peeled off by the infrastructure layer, both by Cinder and by Nova. And it is an encoding of what is a raw block, I gotta stop saying raw, a block device to the guest, for the purposes of encryption, and so I think that fits. Is this, I can't tell, is this the face that Eric makes when he like hates everybody in the room, or is this the face that he makes when he agrees that what we're saying is fine?
Face.
The explanation of the container and disk format is interesting because as somebody who is not usually in the internals of Glance and just has a passing knowledge of what those things represent, I think what you were explaining there aligns pretty well with what I would have kind of guessed they mean. So I guess this is my thrilled face is what I'm saying.
Thrilled, okay. Okay. All right, so it sounds like what we're settling on is adding a new disk format of Lux to Glance for the bare otherwise encoded version of Lux that Cinder does. We will use QCOW for unencrypted and encrypted QCOW. The metadata on either of them, the generic metadata on either of them, will both indicate that a QCOW is actually an encrypted QCOW, and or for both of them, the details of the encryption within.
And if we actually follow the thought that we began with these patch sets, we proposed that we would unify the formerly called Cinder key encryption ID that was attached to Cinder specific encrypted images into OS encrypt key ID for OpenStack. And we would then attach this OS encrypt key ID, which refers to the respective key in Barbican, to either the image with a disk format Lux or image with a disk format QCOW2 to get the reference to the key, and two, for the QCOW2 image to actually indicate that it is an encrypted variant of a QCOW2 image.
Mm-hmm.
So would that be okay for everyone to have this unified metadata attribute called OS encrypt key ID, and probably other OS encrypt metadata?
The key ID, I think, is the primary thing, right? Like if
yeah,
you got
the
a
primary
key,
thing, yeah.
makes sense to me, and Eric's putting on his thrilled face. So
Yeah, one thing
I agree as well.
One thing I was
that
trying to
makes
think
sense.
through was that currently the QCal2 encryption, I think in libvirt and QEMU only supports Lux v1, and we've had a desire to support Lux v2 in OpenStack and cinder, which is supported for like host attached device mapper encryption stuff, but not QCal. So I guess when thinking through metadata fields, just realized that probably at some point there will be Lux 2 support in QCal2 as well. I assume anyway.
yeah, Melanie can probably speak more authoritatively here, but I think that there's kind of a weird support of v2 only with the Ceph driver, which I don't know if that indicates that they have no plans to expand that, or that's just like the one they did to scratch an itch and eventually we'll see the rest. But I do think that we need to keep track of the fact that these are all v1s, so that when we have v2, either in a Ceph case or in the future generic case, we need to know.
Yeah, that's my understanding as well.
And my inspector, I believe, only does, it's been a while since I read it, but I think it only inspects or discovers v1 at the moment.
The thing is, would this need to be represented in the image metadata attributes? With the approach that we were sketching right now, we said we leave the disk format QCal2, and we just attach a metadata called OS_encrypt key ID, which kinda suggests that it is encrypted, but it doesn't say looks explicitly. It doesn't say looks 1 or looks 2 at all.
Well, I think what Eric was saying is that we probably should have another OS_encrypt format version, something really long and easy to type, but that gives us something there, because, like, for example, Nova would need to, or would want to, not send those images to hypervisors that are too old to support them. Otherwise, you end up with this black hole thing where you keep trying to boot, and Nova's like, I know, the best possible instance or place for you to put your instance is over here on this old hypervisor that doesn't support your image. And you just keep sending there and failing and failing and failing because you can't boot, right?
Yeah.
So we need to, this is a thing that right now it doesn't matter because it would all be the same format. But as soon as you start having v2, we'll need to know that a libvirt version is required.
Well, I think it's also that there's some flags in the QCal2 format. There's some kind of encrypted Boolean flag in there to represent the old weak QCal2 encryption that was not Lux. And basically, we don't want anyone to use that, but we want to make sure there's not confusion, because it's probably in the tooling we use that exists somewhere still.
You mean we don't want them to use it once we can support the newer one?
No, there's an actually even older implementation of encryption in QCal that isn't even Lux v1.
That we don't support at all.
I see.
Just want to make sure that we don't make a mistake somewhere where we say encrypted QCal2 true and then have that translate to the one that's not Lux.
Okay. Melanie would, I'm assuming Melanie knows what you're talking about.
Sorry, I was looking at something else and missed that part.
He was saying that there's an older version of encryption pre-Lux 1 that QCal supports that we want to make sure we don't ever generate a thing with that.
Yeah, definitely don't want to use that.
I was looking through the spec, and right now we have also proposed OS_encrypt format, where this should be the main mechanism used, and there we can go in with something like Lux v1 or Lux v2, maybe.
Yeah, that's fine. As long.
Sorry.
No, go ahead.
I mean, I believe you can do if we are already doing sanity checks on QCOW images because of all the CVE stuff and all that, I think it's pretty simple to check the encryption format looking at the QCOW header with the QEMU image tooling, and we could even implement a check in Glance or wherever with the image inspector to validate that the OS encrypt format that we communicate in the metadata is actually the one present in the image, if this is any help.
We probably are not pulling out that chunk of the QCOW yet, but I think that we could. So if you want to take a look at that, that would be awesome. And I agree, it would be, you can imagine all kinds of attack vectors where you, basically the same sort of thing where you tell Glance this is a, Lux v1, but you actually have the old encryption in there, which causes us to not do other things that we should not do, or any other number of things, right? So yeah, that seems like a good additional sanity check to add.
I just wanted to mention one use case. When Glance is using Cinder as a backend, then we cannot create encrypted volumes. Right now, at least it's blocked for NFS, but Cinder will allow you to create, like it will say, like you can create encrypted volumes with encrypted volume type, but it doesn't have the encryptor and decryptor there on the code. So it doesn't actually create an encrypted volume. So that case might need to be handled. I think I can propose a patch to block encrypted volumes completely for the Cinder driver for now, but just a case I wanted to mention.
Okay, I did not fully follow the use case. Is this about some kind of thinly provisioned volumes that are based on an image that is accessible and present in both in Glance and Cinder because they share a storage backend?
Yeah, so I'm not referring to Cinder in this case. So as I understand the workflow, we can only create a volume from this encrypted image if the volume is also encrypted, right?
Yeah. It's sensibly copied web time. Yeah.
Yeah. So when you are using Cinder as a backend for Glance, like Glance images will be hosted in a Cinder volume, then you cannot create these encrypted images in that scenario because it will require an encrypted volume, and currently the Cinder backend for Glance can't handle encrypted volumes properly. So that case might need to be handled or blocked.
Well, the volume's not encrypted, right?
Right. You're just putting encrypted data in an unencrypted volume, right?
Yeah.
Yeah, that should be problematic.
I mean, I can work on the encrypted decrypted layer. It won't be hard, but it will require some testing. I was looking into that area to fix that, but some priorities changed. But yeah, I can, if you want to support that, then yeah, I can look into that.
Well, I don't think that's needed for this, because for this, from Glance's point of view, it's just consuming a plain Cinder volume, and it doesn't care about volume encryption.
And the payload is already encrypted, so it doesn't need to be stored in another encrypted place.
Yeah, I mean, Glance doesn't decrypt it on retrieval or when it's receiving it. So,
but even still, I mean, it's beside the point. Like you might want to have that support for Glance in general, but I don't think it matters whether the image itself is encrypted. Like if you want to double encrypt it, that's cool. If you want to encrypt just the Cinder and store plain text images there, then that's fine. But like they don't seem to overlap to me.
I think it might become an issue when you're copying an image and you're using Cinder as the backend. I mean, because no, I guess that's okay. Because the fast workaround is you're doing cloning in the back end instead of,
Mhm.
but I guess you clone bit for bit. You don't have to decrypt anything. You inherit the encryption keys, then everything should be okay. So you don't need to actually decrypt it until you actually consume the image.
Right.
All right.
So Nova is getting ready to start the knockout, drag out, eventlet removal thing. Are we good to go join that mosh pit? Do we think we need anything else from me and Melanie? It sounds like we've got a plan and everybody's pretty happy with it.
So it sounds like we have the new disk format of Lux. We'll have metadata to disambiguate which kind of Lux it is in terms of V1 or V2. So nothing for now because it's all V1, and then
V1 for now, I would say.
Yeah.
Don't do nothing, because then we have to worry later about nothing or
Yeah. Yeah.
So we want to do that over Lux 1 versus Lux 2 as two different disk formats.
No. Oh yeah, I wouldn't.
Metadata.
Okay.
Yeah, they're intended to be somewhat compatible, so I would.
Okay, so we got Lux as the new disk format, and then we have the new OS encrypt format metadata to say Lux V1, Lux V2. Okay, cool.
Yeah. And one last thing would be that, which we also started in the patch sets already, that if Cinder receives a QCOW2 encrypted looks, which it cannot handle right now for volumes, it will simply use QEMU image tooling to convert between the formats to flatten the structure into a, let's say, raw looks format, not the QCOW wrapped one.
But it can't do that without the key.
Yeah, it has access to the key because of the Barbican secrets that contain the keys.
I thought you were saying
that's not a problem.
I thought you were saying that it can't do that today.
No, the thing is what Cinder can do today is to have QCOW2 encapsulated lux in the volumes. It just can have raw lux in the volumes, like it does encryption today.
Usually. So in the NFS driver, we have that QCOW2 encryption part show up, but
okay,
still some issues to work out there, but the guts of it are there. But in general, yes, Cinder doesn't want QCOW2 volumes.
So we would simply convert at this step to get it compatible to the volume.
Yeah, so in creating a volume from one of these images, it'll go through QEMU image convert and get written out to a raw device.
Yeah. So one last thing that's on my mind here is just out of curiosity. I haven't really looked into it very deeply yet, so please ignore my ignorance. But how is the state of QCOW2 and lux in Nova for ephemeral storage encryption? Is it already a thing fully, or?
No, it's not. There are patches that I worked on for it, but we haven't merged any of that. So it's not a thing right now.
Okay, but it is a potential goal to have it as a back-end drive for encrypted ephemeral storage.
Yes.
I just want to make sure that everything that we are doing now with the OS encrypt key ID and format and the glance format will also be useful for this stuff that Nova will do maybe in the future for ephemeral storage.
Yeah.
Because this is our goal, to have a unified format and handling, so that maybe also Cinder can consume those in the future and Nova can consume Cinder images or whatever. So that's more interoperable than it is right now.
We might have got it done this past cycle had there not been this giant freight train of CVEs that ran through the living room. That really kind of messed everything up.
Yeah, but now that I look back at it, I'm more happy with the distinction between the disk formats and the way we are handling these two variants now that we would have with the metadata alone.
The first silver lining
To be
I've heard.
honest.
Thank you for saying that.
So Marcus, I have one last question from Cinder side. Like, so when we upload an encrypted volume today, does it create an encrypted image? And if not, then does your feature handle that case, uploading an encrypted image volume as an encrypted image?
So if Cinder today uploads an encrypted volume to an image, then the image inherits the encryption because it's just a WebTime copy of the Lux blocks. So this is actually the single edge case in OpenStack where encrypted images already exist, is because Cinder creates them if you take an image from an encrypted volume. But outside of Cinder, these images are not really usable, neither by Nova nor by users, except for users that know how to unhexlify their Barbican key and whatever. But right now, it's just exclusively for Cinder to, let's say, backup and restore encrypted volumes. But once you create an image from such a volume, it's always encrypted in Glance because it's just a copy of the encrypted blocks from the Cinder storage.
Okay, so your feature might provide Nova the way to handle these kind of images now.
I mean, if Nova decides they want to adopt the raw Lux format in addition to the QCOW2 wrapped one in the future, they can choose to do so. Our patch sets will lay the groundwork to have all this in a unified and understandable format so that any component can create and consume these images in a standardized way. And this will also include users. This is the goal.
Yeah, one of the benefits there is that you can actually create an encrypted image and put it in Glance and use it without having to generate it by going through a Cinder volume first and uploading it and all that.
Yeah. That was my main concern, for Nova to use it directly. Yeah, thanks, Marcus.
Okay. Are there any other points that come to your mind regarding this? So maybe just as a short recap, I mean, Dan already rephrased this. Let me just summarize it, what we agreed on so far. So we would introduce a new disk format called Lux. We would add support for Lux encryption to the existing disk format QCOW2. For both, we will add new metadata like OS encrypt key ID and OS encrypt format, which would represent both the reference to the Barbican key as well as the exact Lux version that is or was used for encryption. And if we have Cinder consume one of the new QCOW2 plus Lux images, it will be able to convert it into raw Lux so that it can be used just like the Cinder specific stuff that's currently implemented. And one thing that I haven't touched yet in this conversation, but is more or less already agreed on, is that all of the involved parties will be able to support two kinds of Barbican secrets here. This is just a very specific thing because Cinder up until now was using Hexlify on Barbican secrets because it expected them to be binary content, and in order to unlock a lux volume you need a passphrase, and this needs valid characters, and binary is not always valid characters, so it used hex conversion through the Python Hexlify, bin ASCII Hexlify function. And the so the difference here will be that we have this Barbican secret type called passphrase, which will make then all components interpret it as a passphrase already, and will skip the Hexlify that would have been done up until now, and any other Barbican secret type, just as opaque or whatever, will then still be handled with the Hexlify. This will keep backwards compatibility with what Cinder is doing, because Cinder is creating Barbican secret with the, I believe, opaque type. I know it is at least not passphrase. And this way it keeps doing its thing with the Hexlify. And any Barbican secret that is not explicitly marked as passphrase can be any binary content and will not break any of the passphrase handling. But if it is passphrase, which is not something that Cinder would do, but which we intend for end users to do, because they don't want to dump binary stuff into Barbican, so that they can directly represent the passphrase of their lux volume in a Barbican key. And with that, it goes both ways. So you can either have direct passphrases in Barbican, and it would support that, or you have the way that Cinder does it, where it uses binary representation in Barbican and then converts it. I believe that Nova once said they wanted to use passphrase as a type and not use Hexlify.
I think there was some work proposed a few years ago to maybe move away from using the binary key format. We should probably look at it in Cinder, because I don't know if there's really a compelling reason to do it the way that we do it now. And I think
the OSBrick patch where we introduced the differentiation and the handling between the Barbican secret types, which would then do or skip the Hexlify step, is already merged now. So in OSBrick, we now have the support. And if we integrate it like that, we won't break any current Cinder functionality and implementation. We would just extend it to also be able to handle the passphrase type, which would then skip Hexlify. And this also then applies to Nova automatically, because they both consume the OSBrick library. And in the future, we could then phase out the Hexlify stuff by simply switching to the passphrase type, and then it would happen automatically. And as a transition phase, we can support both without breaking anything. I think that is a pretty attractive approach from my point of view.
Yeah, I think the reason to keep the old one is just that, right? Barbican can be set up to do pure random fills, and Cinder, and as far as I know, Nova don't do that. So I think you get stronger passphrases by doing it
you have,
now.
You have the HSM generate it for you. Yeah, that could be.
I mean, anyway, something to worry about in Zebra or whatever.
Yeah. The other thing that we need to look at for Cinder encrypted volumes in general related to that this is making me think of. So this work is using the secret consumer API from Barbican, and we are still not really doing that for Cinder volumes, and it probably would be a good thing if we did. So I'm assuming that since this work has a patch set using it, that whole system probably is in pretty good shape now to be able to use for Cinder if we wanted to. So we should really look at that as a way to just harden the encrypted volume support in Cinder. As far as key management issues.
I mean, for the places that the patch set touches, it will implement the secret consumer stuff for the encrypted images.
Right.
Okay, then it would be okay for us to keep the already merged OS brick behavior so that we differentiate based on the Barbican secret type and have interoperability between both approaches and keep the things that Cinder does now as they are, but also provide new possibilities for user to have easier key handling if they want to. Does that sound good?
I think so.
Rajat, we have your new location API discussions that have, I'm just realizing we have kind of flown past our time, but maybe it's okay. Maybe we can just roll right into that one. That is
Cyril's still here, so we got a glance representative.
Almost left. It's more of a discussion that they wanted to conduct, and I decided a topic. I can say, okay, Cyril also left. So we need. So does the Glance team has any slot today or tomorrow? I'm not aware if they can provide half an hour for this discussion.
Yeah, I'll see if I can reschedule it. It looks like they've got a 10-minute break now, and then they are going to come back and start with Eventlet according to their Etherpad. I wonder, it might be to listen to at least the opening part of their Eventlet discussion. I'm curious to know what their approach is going to be. We have some Eventlet discussion of our own to have. But that aside, we're pretty open. We've got an hour left of session officially. The only remaining topic we haven't talked about is Eventlet, and there are a few topics added by Tobias and Stephen, but I have not been able to reach them to confirm a time for that. So that's going to push to Friday unless they show up pretty soon. So what do we want to do? We've got an hour. What do y'all think is the best use of this time.
I think Steven's things were mostly, he's got patches up and needs reviews. So maybe we could do that in this time. And I think the same thing.
Okay.
Tobias didn't do a link, but the adding the query parameter, I remember seeing a patch, but I can't remember if it was a spec patch or a regular patch. Because my comment was just whether we use query parameters in our API or not. And I think we do in some cases. But
I think we have some.
If you have time right now, I see I also proposed to just talk about the volume type metadata progress. We could also.
Let's do that. That's a good one. Yeah.
Yeah, thank you. So I have a patch set. I just copy that. So I started implementing this, and I closely followed the extra specs workflow that's already been established. I have 2 patches for Cinder, one that just introduces the new database table, and another one that introduces all the API stuff, which will include a new micro version. I think that is necessary. And I followed the documentation on that. And
so Josephine, can you please provide an overview why this was needed, the use case for this?
The use case for this was that the volume types from a user perspective needed a way to machine-readable describe properties that are not used for scheduling purposes. So we need something like in the extra specs, but not for scheduling. And that's the reason to have a metadata table that just has things like this is encrypted because the encryption type is also not visible for normal users. And you can also type in something there like replication true because it is replicated in the backend by Ceph, but not replicated by Cinder. So Cinder doesn't know anything about this. And it would be good to have something like this. So it is filterable. It is possible to detect and not to having to look into a description which some providers have filled out and are detailed, and some don't have this. Sometimes I see just 3 times replicated, and I don't know, why is that true? And it is a good reason or a good chance to have some description of volume types that can be used for in a machine readable way, so that, for example, something like Kubernetes layer on top can decide, a managed Kubernetes can decide, I need that kind of volume type or that kind of volume type. That's why I started implementing this. And that's why I closely followed also the extra specs workflow. And yeah, I just wanted to shortly give an update about this. All the patches I wrote, I've tested together in the dev stack to going through this, and I can use this. I can add new metadata, and I can see it, and I can filter by it. And I just wanted to raise awareness about this, and wanted to ask if there's anything more I need to consider when adding a micro version, or is there anything else I need to do, except for writing more tests.
So basically, like, let's say a consumer of OpenStack like Eventlet is trying to consume Cinder volumes and they want a replicated or encrypted or a multi-attached type per se, then they can query this metadata. So we need to have them in a proper format, right? Like multi-attached shouldn't be without dashes or something, like some format where this metadata should exist, like, or it could be, I mean, there should be some uniformity. There will be some uniformity in the way key values are stored, right?
Yeah, I think the idea was we were going to use glance metadefs to define the keys and the values.
Yeah, that was the idea. But before doing so, we need to have all that ready.
Yeah, so if we use the metadefs, then like Horizon can display the stuff in drop downs when you do a create volume type.
But yeah, the code right now just put whatever in there, right?
Yeah, so we were going to leave that to so we weren't enforcing anything, I don't think. It's just that was going to be part of the general effort.
Otherwise, it's hard to be machine readable if the format just is all over the place.
At least we can use the same, like, basic validations with the same format we have, like multi-attached says is true with is in the brackets. So the same format we can enforce.
I don't know, that format is not great.
But we use it for extra specs, so I mean, just keep it same as how we use it.
But this is not going to be like automatically populated, right? This, like, an admin has to go type this stuff in here, I think.
Yeah, there's at least for something like replication, when there's a Ceph backend, you need an admin to type that in. Because OpenStack doesn't know about what Ceph is doing in the backend and whether mirroring is on or not.
So what I was trying to say is, like, when an admin is creating a volume type, and he's setting the extra specs with multi-attach is true, they can use the same thing for the metadata of the volume type. So it will be easier so they have to even type it for extra specs as well, the same things.
No, I get what you're saying. I'm not sure I'm convinced that it's easier, but I mean, I don't know if that makes sense.
Would be good to have, I think it'd be good to have as like a phase 2. We could do some kind of validation when you are creating. Although I don't know if we want to do that, right?
Well, the is true applies more when an admin is creating the type, but this user visible feature is more about the readers, the consumers of the information.
Right.
Well, and I thought this premise of standardizing on metadefs later, does that not prescribe any kind of format?
You'll have to once you put the patch up. I mean, most of the metadefs are pretty much free form. I mean, you've got the usual like 255 character limitation, probably UTF-8.
The problem with the extra specs format is the like the is operator is just weird. It could have been like equals equals or something like it would be everywhere else on the planet, but we made it in, you know, angle brackets. And I mean, I went through this exercise looking into how that format works the other day with the or operator, because it has and or and some stuff you can do. And the or operator in there doesn't even work the way I thought it would. It's actually like really weird. So I'm skeptical that we want to populate other places with that same format. Because you can't, like the example that I was doing was, you know, I wanted to check like volume backend name A or B. A or B doesn't work. You have to say or A or B for it to parse in the way that it actually works. And we don't document this anywhere, so I wrote a bug because there's stuff that you can do in there that we don't explain how to do, and it's weird. So I don't know. My point is, I'm not sure that the format that we invented in that space is particularly brilliant. I mean, we can do it, it works, but I don't know if that would really make people happy or not.
I guess the key thing is, as part of this, to at least document where we sort of expect it to go, so that operators don't just make up all sorts of stuff and have problems later with interoperability. Although I guess it's kind of fairly cloud specific. I don't know.
Well, if you're doing that so that Kubernetes can find what volume type it wants, you have to go into Cinder and specify this field that says multi-attach is supported. And then you have to go into Kubernetes and specify on that end how to detect that field and how to look for it.
Interestingly, that's already supported. I mean, the existing user visible extra specs, you don't need metadata.
Right. It is for a couple of things.
Yeah, with just a couple of examples that have come up is replication and multi-attach.
Yeah, but with replication, you can't represent the backend only replication, is what's kind of sparked the whole discussion.
Okay.
Yeah, the difference here was really that this is for admins who want to kind of handcraft a type that says this type does this thing, and I mean this by it. And
All right, so I guess the main thing is, Josephine, you need reviews and comments on your reviews.
Yeah, and I also wanted to discuss if we are agreeing that I keep going on with this and that I'm going into the right direction with the patch set.
Okay, well, we've got the spec was merged, so that should give reviewers an idea of what you're trying to accomplish, and then we can use that as we look at the code patches.
have you looked much at if there's any performance needs for certain types of database indexes with this?
I don't think so. What exactly do you mean?
Well, we've had numerous cases in Cinder where when somebody has 1,000 of whatever in the database, we find that it's a lot slower than it should have been because we didn't index the table properly. So mostly what I'm saying is, in reviewing this, I want to kind of stare at that and figure out if there's any particular thing we should optimize for indexing on that.
On the plus side, it's volume types, so there shouldn't be too many.
Yeah, that's.
But that's a bad assumption to make, right?
Some odd use case, and you know.
I wrote it down to consider. And there was one question in particular that I noticed. The extra specs code in the API does send notifications. And I wondered, do I need them too, or don't? Is it not needed for the metadata?
What kind of notifications do we send related to extra specs now? That seems surprising to me that we send any.
I'm thinking, without like knowing what I'm talking about, the notifications would only be useful for the actionable extra specs. So since these metadata things are meant to be meta, we wouldn't want any kind of notifications involved in this.
I think that's probably correct. And if we need them, we can add them later. I'm looking at the code now and I see that we add some, like if you try to create a new volume type and you've, I guess, tried to create one that's the same name as one that already exists, we send a notification for that, stuff like that. It's not obvious to me why it would be useful to add notifications to this part, I guess.
Yeah, that's what I wondered. So I will just not doing notifications for now.
Yeah, I think that makes sense, because if we find a good use for them, which would mostly be around usability for clients or something, we can add them later.
Yeah, I'm surprised to see that we're doing notifications there.
It's probably to support manipulation of volume types through Horizon, I would guess. I don't know. It looks to me like we can go review this stuff.
Steven's patches and Tobias, or
we were talking about Josephine's
stuff too.
Probably those two. I think let's prioritize Josephine since she showed up.
Great. I'm going to stop recording. Unless there's an objection, I don't think we need to include this part in the, on the record. Not that I think anyone will watch these, but just in case, we can at least spare them from this part. Alan, are you there?
Yeah, what's up?
I just had a thought about, I was listening in on the Nova discussions. It sounded like you had some doubts or concerns about the ability to quiesce from an in-use volume. Or
Yes.
not true. Okay. It might be helpful to take a look at Sekiyama's work on instance backup. The ioctals specifically that you're looking for are FS freeze and thaw, and these are syscalls that are.
It's not about quiescing, I don't think.
Oh, all right. I thought you wanted to. Okay.
We need to stop IO at the right parts, but I unless I'm missing something, the whole thing about quiescing is like not really part of what we're worried about.
Well, should you be worried about it, you can access it through the guest agent, and Sekiyama's work on instance backup should be a good example of how it works, and it is present, so it is available should you decide you need it.
Yeah, this is something that would all have to be over on the Nova side, and
Mhm.
you know, a whole API between them and all that. I mean,
yeah, his work includes like his stuff communicates with Cinder, and Cinder talks back to Nova, accesses the instance through the guest agent, quiesces the file systems, creates the snapshots, and keeps proceeding. It might be a useful reference to consider.
yeah, I might need a specific pointer to the work, just so I can go find it, John. But I'm now starting to think that, you know, are we solving a problem that doesn't need to be solved? I mean, the whole notion of the driver assisted migration sounds great, and honestly, I unless I missed something, I think it would be trivial to reinstitute the patch with a tweak that basically says, oh, geez, volume attachments, sorry, never mind, we're not going to use, driver assisted. And if nobody's been complaining about issues related to having Nova do it, because it sounds like Kimu just kind of magically takes care of it for you. And, yes, there may be a load on some other resource, like the network, if it's going to read from one and write to the other. But if nobody's complaining about that, then this could be one of those cases where, implementing a solution would be more painful than the original problem that we've been living with all along and no one's complained about.
Well, the motivation is that there's a perception that we could be doing migrations in a way that perform a lot better IO-wise, and we're not, but we could be.
Well, when they're attached or not, and that's what I'm trying to distinguish, is whether or not they are separate enough use cases that need their own treatment.
When they're attached, because it's, I think for most actual users, while volumes are attached are really the case they care about with the migration stuff. Because I don't think that many people are migrating around volumes that aren't attached, and when they are, it's less impactful on things you're running anyway. So I think there's some good performance gains to be had by doing this with the optimized path. My concern after looking at it with you the other day and talking to the Nova guys, I am still, I feel like I'm missing something in this whole picture of how migration of attached volumes actually works. Because the way I thought it worked doesn't seem to match up with what's actually happening. And I don't know, I want to go figure out, at least what is going on in there now. Because I'm concerned now that there might be other bugs lurking in there that we're not even aware of.
Do you have something a little bit more specific?
Well, we had, where we have arrived right now on this work was because we introduced the patch that enabled optimized migration in more cases. And then we reverted it because it clearly caused data loss because of no vendor not coordinating correctly on the volumes. I am trying to figure out now if there is a similar problem that still exists even in our current implementation using the generic migration method through Cinder. Because I don't have a clear picture of when we're moving data through various parts of this migration process, if Nova and Cinder are actually making all the same assumptions about how the volume is being used and whether IO can still happen while these things are occurring. And so one thing I really want out of this whole analysis we've been doing on this stuff is to draw out a picture of how this stuff actually works and what the state transitions are as far as when data is being migrated by Cinder and when data is being written by Nova, and just make sure it all lines up, because in my head it doesn't all line up correctly now, and I don't know if that's me or if there's like other problems lurking in this area.
Well, there's definitely code in the Cinder that decides whether or not it's going to attempt the driver assisted. And if you do go down that path and the volume is attached, then you're screwed. And there may actually be circumstances where that can be triggered now. It was absolutely triggered by the patch that was reverted. But if the Cinder code says, nah, I can't use volume assisted, and it goes down the generic path, then the fork in the road is, are there any attachments? And if there are attachments, we pretty much say, over to you, Nova. And Nova has, you end up down in the libvirt driver code, and there's a function called swap volume. Actually, there's a couple of similar ones because there's like swap volume and do swap volume and underscore swap volume but whatever. But anyways, It gets to the point where it will basically start doing, libvirt voodoo to copy the block device. And then they have a, pivot once that job completes.
And Alan, I just wanted to mention, so you had this concern that people might not be using attached volume migration. And I have seen a few cases where this type of migration can take days, like 2 terabyte volume taking 3 days to migrate. But people don't generally, I think, complain because they do it once in a while, like they don't switch backends very often. And a few GBs could also take hours. So the Nova thing is very slow. So if we can introduce this optimization, it might help some of the people that I have seen that wait hours and hours for this migration to complete or attached, because they have both from volume. So
Sure. No, it's good to know. I thought that, if it took 3 days to migrate, that's fine. Who cares? I mean, libvirt's got you taken care of. Just let it roll. But if that 3-day duration is a problem, then yes, we do have something worth working on.
Yeah, because the complaint was that the volume is stuck in migrating retype state, and it completed eventually after the desired duration. And our analysis also showed like the migration is still in process, but the end user might not know, like if it's taking this long to complete, then is something ongoing here, or is the operation just stuck? So that kind of scenario has happened.
Okay.
Steven has jumped on real quick. He's got a couple of topics that he'd added to the agenda. If now is a good time, we can roll through them.
Sweet. Yeah, I'll be brief. So I'll start the uWSGI scripts change first. So Eric, I see you've already +2'd that. This basically, it just needs another +2 from someone. The context of this is due to changes in the Python ecosystem, PBR isn't going to be able to generate those WSGI scripts anymore. The hook points that we were using is disappearing. And we don't want to effectively have to write our own packaging tool instead of just piggying back on setup tools like we currently do. So we need to either start carrying WSGI scripts locally or adopt a module-based configuration system, which is what's supported by like GUnicorn and pretty much every other WSGI framework out there. So that's that change. There's a Cinder aspect to it, and then there's a DevStack aspect to it to switch over. And the WSGI scripts will stay around until we get to, I think, pip, whatever version of pip comes out next year, and the setup tools that will come out around the same time is the thing that will eventually remove it. So it'll break after that, but we should be okay. That's that one. And then the other one is I have a spec that's been open for, I think, about a year. We have been adding OpenAPI schema. We have been trying to develop OpenAPI schemas for a lot of projects. We are doing that on a project level basis by adding JSON schemas for a lot of the, for pretty much all of the APIs, except for like the really old deprecated stuff. I think I talked about this at the last PTG anyway. That's effectively needs reviews. And and feedback from people as to with regards to my direction and stuff to make sure that everyone's happy with the direction. So I have links left to both of those. Of those, the uWSGI one is probably more important because there is a timeline of whatever version of pip and setup tools is coming out beginning of next year. That's going to break us if we don't get this merged before then. But the OpenAPI stuff, as I've noted in the release note, I have no schema changes done yet there. Pretty much everything that's there is getting rid of the remnants of the V2 API and merging them into V3, which is probably long overdue at this point. So it should be hopefully relatively easy to review. And that's my spiel. I have nothing else to add.
Thanks. We'll see.
Any questions?
We can get this taken care of on this cycle.
Ideal.
I think these have been up for a while. I remember this coming up in the last one.
Yeah. Yeah. Hopefully they shouldn't be too tricky to review, either of them. Lovely. That was easy. Any questions? And if not, I'll drop and leave you to it.
I'm just confused with the lock part there. When we are initializing the uWSGI application, then we do it in a threading lock. Just wanted to know the reason for that.
That is copy paste from what PBR was doing in its uWSGI script generation code. I don't know if that's relevant. I'm pretty sure that most Eventlet servers use process pools as opposed to threads to launch new instances of the server. So I don't know if it's doing anything, but it's what we had been doing in the uWSGI script for years, and there was no I couldn't find any context for why it was originally done that way in PBR, and I was neither interested nor clever enough to figure out if it was truly necessary. So it's copy and paste.
I think it's done so that if you initialize this uWSGI service in a multi-threaded environment, you don't have each thread try to start one up.
Yeah. So but like I said, I'm pretty sure that like most of them, I guess they do allow you to use threads. Most of them do tend to I think gUnicorn uses process pools. Just if you want to enable like concurrent processes. I don't know how many, if any, are using threads, but if there are a few, that would make sense. But like I said, nothing has changed from uWSGI script here, so.
Yeah, if it's consistent with what we already do, then yeah, that's fine with me.
Sweet. Spot on. Okay, I'll drop in that case. Give me a shout on IRC if any questions come up later about this. Thanks for your time.
Thanks, Tim.
Cheers.
So minus Tobias's topics. I haven't heard from him yet. We can talk about Eventlet. We've got about 20 minutes left, or we can talk about that tomorrow. There are a few NetApp related, driver related topics tomorrow that they are only available on Friday for. So those will remain in tomorrow's agenda. Otherwise, that is about it. We are nearing the end of our talking points here. Does anyone have an appetite for sharing thoughts on Eventlet, or do we want to save that for tomorrow?
Well, I've been going to the Eventlet stuff to try to learn some things about it and what we're going to need to do. I don't know. Do we collectively know enough about it to have much of a discussion yet?
I'm not sure. We might have to have a discussion to determine if we should have a discussion. I think so. If we were just using Oslo, we could wait for them to implement their solution and then just gain that. But we also use Eventlet directly, so those specific uses are going to have to be replaced. I talked to Cyril briefly, and he is. It's worth mentioning that Epoxy is a Slurp release, and so their strategy in general is to propose and land as many like periphery sort of easy and non-disruptive patches as they can, and they're going to save the potentially disruptive ones for the beginning of the F cycle. The goal is to essentially merge all of the simple things in this cycle and have the larger pieces that complete the effort kind of loaded so that they're ready to roll for F.
Yeah, there are some easy to remove Eventlet references. We have a lot of code that calls import eventlet.sleep, which is wholly unnecessary for us to do. So a bunch of stuff like that we could just rip out.
Maybe it would be good. I created an Etherpad just as a placeholder. Maybe it'd be good to just list all of the reference, like the direct uses, and sort of just check them off as we go.
I think that would be very useful, is to sort of have a hit list, and if we can start categorizing things in terms of like low-hanging fruit, and
yeah, we could bucket all of the like eventlet.sleeps into like one group, and then tackle that set at as a single patch set, and then sort of divide things up like that. Maybe that would be a good way to organize it. I can do that. I'll update the Etherpad to list the direct uses, the things that no one's going to give us for free that we're going to have to do on our own. There are a lot, but
the bigger questions, I'm still trying to figure out how much we're going to get for free, because there are some architectural changes that I think we have to decide on, like for Cinder API, is it going to use async IO? Are we going to do threading stuff? I think different projects are going different directions with questions like that, and we'll need to evaluate what we actually need and what would be easiest to do.
Yeah, I had similar concerns because the Eventlet wiki page just says like either use thread pool executor or async IO.create task. I mean, we should standardize this across, I think, all the projects.
But it won't be standardized across all the projects, because it turns out, from what I understood in some discussions the other day, if you have an API like the Cinder API, where, as far as I know, we don't really have any long-running API operations because they all just hit the database and then something happens somewhere else. It's one model where it's just the API service is doing CRUD kind of stuff. The other API model is something like Glance, where you open an HTTP connection and shove 100 gigabytes of data through it, which we don't do in Cinder. And one of the notes from a call I was on the other day about Eventlet stuff was that difference in the types of operations those API services are doing means that async IO versus threading will fit better depending on which situation you're in.
But do you know which one is likely to be the one we're going to lean towards?
I should know, but I have to go look at it some more because I don't remember that part.
I was mostly concerned with like shared libraries like OSBrick. So Cinder also uses it, Nova also uses it. So that's kind of a code that should work with both, like whichever alternative Nova or Cinder goes with. So that's why I was thinking of like standardizing. But
yeah, I don't know what the approach is for things like OSBrick. I don't know if we have to rewrite it to do async IO things, if consumers of it should just put it in some pool and let it do its thing. It's a good question, though.
Just a quick grep. It looks like there is not a lot of OSBrick usage in Brick. Sorry, Eventlet usage in Brick.
No, because it's
actually only a test requirement. So
right. But there are implications if there is a need to have a OSBrick support async IO. I don't know if there's a need for that or not yet. I haven't really gotten that far into investigating this. The other place this shows up is when you have dependencies that use native C libraries like librd and Cinder. That has weird implications about how it works with threading and Eventlet and threads, and we need to understand the requirements around that. Because when you get into things like librd being a C library, you can't just assume Eventlet or something like that is going to just do the right thing, because they don't behave the same way.
right now we wrap them around native threads, right? Like the calls to librd and the RBD driver.
I think that is what we do now, yeah. We used to put them in an Eventlet thread pool, and then we moved them to native threads because we realized that they would behave better that way, I believe. So one of the big kind of tasks on this is just going to be to gain some knowledge about async IO and threading and the implications of which one we're using where, and figure out like which one fits the API service, which one fits the volume service.
So I had a very general question about it. So we started using Eventlet because it provides green threads, like user level threads to do like multi-threading in a way in a Python environment because of GIL. And now we are switching back to native threads. So I was just concerned with the performance. Maybe we might have operations being blocked by native thread, because Cinder volume, I think, only runs single threaded.
Well, I don't think it was done because of the GIL, but because what it does is it lets you have multi-threaded code that's not actually multi-threaded, but you can pretend it is, which is convenient for implementing things. The question for things like Cinder volume would be like, if you have a volume driver and you assume that it's going to at times be doing 12 different operations at once on various different volumes? Do you spin up a pool of threads with different instances of the volume driver? If you just use one and you remove green threading, suddenly you have a bunch of bottlenecks. Do you have to convert the Cinder volume driver API to use async IO methods? Presumably that would not be what we would want to do, because it would probably be a nightmare.
Okay. And if I'm doing any CPU bound task, like let's say converting an image, and another request comes to do the same for another volume, I mean creating a bootable volume from image, would that wait for it or just, I mean?
Well, it can't, right? Is like, we have to do something so that it doesn't wait for minutes before doing the next one. My assumption is that that means that we end up with volume drivers running in a multi-threaded environment. But I have not dug into this far enough to understand the exact implications of doing that.
Okay. Yeah, I mean, we can document all these things, just some thoughts around how current operations will work in that scenario, just thinking about them.
I mean, it may be that we can use async IO stuff to dispatch out volume driver calls in a way that's behaves similarly to what we have now, but I have no idea if that's possible or not yet.
Okay.
I just posted it's a work in progress, just a work in progress, just to see what kind of gate errors we're going to get. That's a break patch that removes all of the Eventlet references. There's just a couple of mocks and the test requirements. I'm sure there's more, but I was just curious to see what comes of that.
As far as ability, as far as ability to other projects, we should really talk to the Manila guys, since they have a very similar API and their service to how Cinder is set up. There's a pretty good chance that we would basically do the same thing. So we should probably combine our brains between Cinder and Manila on the.
Did the origin of Manila, was that a fork of Cinder, or did they start from scratch?
The fork of Cinder, yeah.
Okay, so then yeah, it could be.
Their architecture is pretty much the same as ours. As is the fact that they have to call out to drivers that will spend 2 minutes doing an operation with an external SAN or whatever, and a lot of the implications should be the same between the two projects.
You're muted, John.
Five minutes remaining. Yeah, I used to be able to hit the space bar and it would toggle. That seems to not be working. I think sometimes things work, sometimes they don't. Sometimes they do things that are different than they did last time.
Yeah.
I don't know. All right, I'm going to stop recording.